In this video, I'll be going over how we can verify that a trig equation is an identity. So what we mean by this word verify, we just want to show that the left side of the equation is actually equal to the right side of the equation. And to do that, we must show that the left side is exactly the same on both sides. So same on both sides of equal sign. Okay, so typically what we'll do is we'll work with one side of the equation and turn it into the other side. Now, this isn't a hard rule. You can work with both sides of the equal sign, but we don't want to move anything across the equal sign. So we want to work each side of the equal sign independently. Okay, kind of ran out of room there, but hopefully you can read that. All right, so it's a similar idea as doing a simplification, but here what we're doing is we're basically simplifying one side so that it looks exactly like the other side. And usually we'll start with the more complicated side. So looking at this first one, I'm going to work with the left-hand side because this side looks more complicated. And so basically what I'm going to do is I'm going to simplify that down so that it looks exactly like sine of x. Oftentimes, the very first move is to convert everything into sine and cosine. So this tangent I can write as sine of x over cosine of x. It's getting multiplied by cosine of x. As we're working, we want to write an equal sign every step of the way. So at the end, all of our equal signs are aligned vertically. Okay, so on the left-hand side, I change tangent of x to sine x over cosine x. Then I keep everything else the same. And then what we can see is cosine of x times cosine of x will cancel. I'm left with sine of x is equal to sine of x. I have achieved my goal. The left side is exactly the same as the right-hand side. And then I like to put a little check mark just to show that I've accomplished this. So that one's pretty straightforward, and as we go, these examples will get a little bit more complicated. All right, the next one, we have secant squared of b minus 1 divided by secant squared of b, and that's equal to sine squared of b, or beta. Okay, so what I think I'm going to do here is, again, the left-hand side looks more complicated, so I'm going to try to simplify that. And on this particular one, I could turn everything to sine and cosine, but then if I change secant squared into 1 over cosine squared, then I'm going to have a complex fraction, because I'll have a fraction in the numerator and a fraction in the denominator. So rather, what I'm going to do is I'm going to split this into two separate fractions. Secant squared of b divided by secant squared of b minus 1 over secant squared of b. And then I'm going to write that equal sign every step of the way. Write the equal sign. Okay, and now what we notice here is that this is equal to 1. And now 1 over secant squared, I'm going to rewrite that as cosine squared. So this is 1 minus cosine squared of b. And we've seen this before. This looks like a version of the Pythagorean identity, right? So if I subtract cosine squared from both sides, I get 1 minus cosine squared. So I can replace this 1 minus cosine squared with sine squared. And I have it. So again, the last step, those are exactly equal to each other. And then I have equal signs all the way down. So one thing to mention is when we're doing these verifications, sometimes these are called proofs, because what you're doing is you're proving that that original equation is an identity by making the left side equal the right side. And so the answer to these questions is all of these steps, okay? So sometimes students like to put a box around the final answer. Don't do that. The last step of these problems is not the answer. All of the work is the answer. So, and that's why we want to be clear and methodical with how we're doing these. Okay, moving on. we have tangent to the fourth plus tangent squared of x is equal to tangent squared of x secant squared of x. On this one, it's not 100% clear which side to work with. But what I'm going to do is I'm going to work with the left-hand side, and that's because I have this tangent to the fourth and tangent squared. So what I notice is I can factor out a tangent squared of x from both terms. Okay, so doing that, I'm left with tangent squared of x plus 1 inside the parentheses. And then on the right-hand side, I have tangent squared of x, secant squared of x. And so this, again, anytime I have a trig function squared and a 1, we should think about one of the Pythagorean identities. And again, this is the Pythagorean identity that you should definitely have memorized. And get into the other two versions or forms. How we do that is we can divide everything through by sine squared or cosine squared. Since in the problem I have tangent squared, which is sine over cosine, I'm going to divide everything by cosine squared of x. And what that leaves me with is tangent squared of x plus 1 is equal to secant squared of x. So this thing right here is going to be equal to secant squared. So I can replace this with secant squared. And that gets me the verification. Okay, so I did one step each line, and at the end they are equal. All right, on this one, well, let's see what we have. I have a fraction on the left-hand side with a couple terms in the numerator. The right-hand side looks like a simpler fraction. So I'm going to work on the left-hand side. And a similar idea to what we saw in the previous one is I could split this fraction. I'll go ahead and do that, and then I think we'll try it a second way. So secant theta over sine of theta minus cosine theta over sine of theta. Okay, and so I'm going to rewrite everything in terms of sine and cosine. So secant I can rewrite as 1 over cosine. So 1 over cosine theta divided by sine theta minus cosine theta over sine theta. And this problem is going to have a handful of steps. And so on the right-hand side, I don't necessarily need to keep writing sine of theta over cosine theta. If I'm not doing anything, we can just bring it down at the very end. But it is important that we write those equal signs so that it's clear when one step ends and the other one begins. Okay, so here, 1 over cosine theta divided by sine theta. I'm going to do this over to the side. 1 over cosine theta divided by sine of theta. This is just a little refresher for you when I'm dividing fractions. That's the same as multiplying by the reciprocal. Okay, so simplifying that fraction is just going to be 1 over cosine theta times sine theta. Minus, and then to combine this fraction and this fraction, I need a common denominator, so I'm going to multiply the top and bottom by cosine of theta, so that the denominators are sine theta, cosine theta. And again, it doesn't matter which order I write those in. And then in the numerator, I have cosine squared. Okay, so combining these fractions, I have 1 minus cosine squared over cosine theta times sine theta. Okay, and it looks like we have another form of the Pythagorean identity. 1 minus cosine squared is sine squared. And so I have sine squared of theta over cosine theta times sine theta. And then what we notice is that this sine is going to cancel with one of those signs. So we're left with this sine of theta over cosine theta, and that is equal to what we had way up here, sine theta over cosine theta. Okay, so that's a quick way to do, not a quick way, but that's a pretty straightforward way. Let's try it a second way here. And so what I'm going to do is with that original fraction on the left-hand side, I just write the original problem. Okay, so what I'm going to do is I'm going to actually combine the numerator into one, see if I can combine the numerator into one term. So secant theta is 1 over cosine theta minus cosine theta, and that's all over sine theta. Okay, and so what I'm going to do is this cosine here, I'm going to multiply it by cosine theta over cosine theta so that I can get a common denominator. And when I do that, I'm left with 1 minus cosine squared of theta over cosine theta all over sine theta. Okay, and this 1 minus cosine squared, we just saw that. That's equal to sine squared of theta. So I have a fraction within a fraction. So this is going to be sine squared of theta over cosine theta, all divided by sine theta. And again, remembering how we divide fractions, this is sine squared theta over cosine theta divided by sine theta, which I'm going to just erase that and change it to multiplication and the reciprocal. So times 1 over sine theta. And simplifying, this sine squared becomes a sine and it cancels with that sine. So what I'm left with in the numerator is sine of theta, forgot to put an equal sign here, divided by cosine of theta, and that is equal to the right-hand side, sine theta over cosine theta. So I don't know which side is quicker or which one makes more sense to you. It honestly doesn't matter. And there's probably other ways we could have done this one. Here are 2 of the possibilities. Okay, moving on. We have sine squared x minus cosine squared x divided by secant squared x minus cosecant squared x. That is equal to sine squared of x times cosine squared of x. This one is a little bit more complicated. What I'm going to do here is I'm going to keep the numerator the same on the right-hand side. And then in the denominator, I'm going to rewrite this in terms of sine and cosine. Okay, and then leaving the right-hand side the same. In the denominator, I need to get a common denominator. So the first fraction, I'm going to multiply by sine of x over sine of x. Then on the right-hand side, I'm going to multiply by cosine of x. Oops, these should be squared. Cosine squared of x over cosine squared of x. Okay, so in the numerator, we're going to have sine squared of x minus cosine squared of x. In the denominator, well, on the left fraction, we'll get sine squared of x over sine squared x cosine squared x minus, and then cosine squared of x over that same denominator. Okay, so putting those 2 fractions in the denominator together, what we're going to have is sine squared of x minus cosine squared of x divided by that common denominator. Okay, and so I have this numerator divided by a fraction. When we're dividing by fractions, that's the same thing as taking that numerator, I'll write it in red here, sine squared of x minus cosine squared of x, and multiplying it by the reciprocal of the denominator. So the reciprocal will be sine of x squared cosine squared of x over sine squared x minus cosine squared x. And I think I left that squared there. All right, so what we notice is that I'm multiplying these 2 fractions together. These are going to cancel. Those are the same terms. So what I'm left with is sine squared of x cosine squared of x, and that is what we had on the original right-hand side. Okay, so that one's actually a little tricky, kind of on what route you want to take there. But again, I've done this one before, so it might look like it's a little bit of magic, but yeah, if you don't know the right direction to go on this one, you're going to end up needing to possibly try a few different ways. All right, this one, we have cotangent to the 4th plus cotangent squared equals cotangent squared times cosecant squared. And I think this one is similar to the one we saw previously where we factored out the tangent squared. But this time we're factoring out cotangent. On the right-hand side, cotangent of x times cosecant squared of x. All right, and then this in here looks like one of the Pythagorean identities. And I'll just verify that. If I divide each term this time by sine squared, that will give me a cotangent squared. So I'm left with 1 plus cotangent squared of x is equal to cosecant squared of x. So this can get replaced with what's in the parentheses. We have cotangent squared of x times cosecant squared of x is equal to what we're looking for. And that does it for us. All right, and then we have one final verification here. And on this one, we want to avoid the urge of cross-multiplying, and we can't do that, although it looks like that might work for us. The reason we don't want to cross-multiply is because the instructions tell us to verify the equation and show that this is an identity. And since we don't know perfectly that this is an identity yet, we can't move things across the equal sign. So the move here is to multiply one side by the what's called the conjugate of the denominator. In other words, we have this expression 1 plus sine of beta, and the conjugate is taking those two terms and replacing the plus sign with a minus sign. So I'm going to go ahead and multiply these now. So on the numerator, I get cosine of beta minus sine beta, cosine beta. In the denominator, well, I have these two binomials. So I'm going to have 1 minus sine of beta plus sine of beta minus sine squared of beta. These middle terms cancel. 1 minus sine squared of beta is one of the forms of the Pythagorean identity. So I'm going to write cosine squared beta in the denominator. And looking back to what we had up here, might be a good idea to actually not multiply those together. So I'm going to undo that multiplication that I just did. And the reason is because now I see this cosine beta cancels with this squared in the denominator. And that's what we're left with, 1 minus sine beta over cosine beta. And that does it.